Computer vision is a field of AI that gives machines the ability to see and interpret the world through images and videos. Instead of just seeing pixels, a computer can recognize objects, people, and emotions, enabling it to understand and act on visual information. We'll explore the foundational concepts behind modern computer vision, which can be categorized into four main types. Image analysis, the ability to detect, classify, caption, and generate insights. Spatial analysis, the ability to understand people's presence and movements within physical areas in real time. Facial recognition, the ability to recognize and verify human identity. Optical character recognition, OCR, the ability to extract printed and handwritten text from images with varied languages and writing styles. The foundations of computer vision, pixels and filters. To a computer, an image is nothing more than a numerical array of pixel values. A simple grayscale image is a two-dimensional array. A color image is a three-dimensional array with separate layers or channels for red, green, and blue, RGB color values. A common way to process images is to apply filters that modify these pixel values to create a visual effect. A filter is defined by a small array of values called a kernel, which is convolved or systematically passed over the image. This process involves a series of mathematical calculations that highlight features like the edges of objects. While this is useful for basic image editing, its real power lies in machine learning. Machine learning for computer vision. The goal of computer vision is to extract meaning from images, which requires machine learning models trained on vast volumes of data. Convolutional Neural Networks, CNNs. Simply put, this is the specialized AI brain that teaches a computer how to see. A CNN is a type of deep learning model designed to process images. Think of it as a step-by-step process where the AI learns to identify an object, say an apple, not by looking at the whole picture, but by breaking it down into simple, recognizable pieces. Images with known labels are fed into the network to train the model. Feature maps are arrays of numeric values generated when filters, kernels, with randomly assigned weights extract features from an image as it passes through the network. The feature maps are flattened into a single-dimensional array of feature values. The feature values are fed into a neural network. The neural network's output layer uses a softmax function to produce a result, such as 0.2, 0.5, 0.3, where each value is the probability for a possible class. The model compares its predicted scores to the true label to calculate the loss, the error. This loss dictates how the internal weights, both in the fully connected layers and the feature extraction filters, are modified to improve accuracy. The entire optimization process is repeated across several epochs until the model is ready to be saved and used for image prediction. CNNs are fundamental to computer vision. Beyond classifying entire images, they are used for more complex tasks like object detection, where the CNN finds features and identifies specific regions of interest to locate multiple objects in one image. Recall from the NLP module that embeddings work by representing a word or token as a point in a multidimensional space. Each dimension represents a semantic attribute that captures the meaning of that word. Now let's combine these embeddings with CNNs to unlock the power of multimodal models. Foundation models are the new standard for modern vision AI. They are massive, pre-trained models, often including both an image encoder and the language encoder, that have learned from huge volumes of captioned data. Instead of building a model from scratch, users adapt these models to create specialized AI for various tasks. For example, you can adapt a foundation model to perform image classification, assigning a distinct category label to the image content. Object detection, pinpointing and bounding specific objects present in the visual field. Captioning, generating complete, natural language sentences that describe the image. Tagging, creating a descriptive, keyword-based index for the image. To recap, computer vision is the AI field that gives machines the power to see and interpret images and videos, recognizing objects, people, and text rather than just pixels. Its core abilities include image analysis, spatial analysis, facial recognition, and optical character recognition, OCR. The technology relies on convolutional neural networks, CNNs, a specialized deep learning model. A CNN analyzes an image by using filters, kernels, to extract basic visual features, which are then processed by a neural network to classify the content or locate objects. Modern AI leverages massive foundation models pre-trained on captioned data, enabling rapid adaptation for sophisticated tasks like advanced object detection and natural language caption generation without needing to build a model from scratch. Next up, computer vision in Azure.